Hello and welcome to this Squishy Volumes tutorial. In this tutorial, we are going to create the scene that you've just seen. Squishy Volumes is an open source implementation of the material point method that is developed by Algebraic, and it's available as an extension to Blender 5. This tutorial is not meant for complete beginners, and I'm going to assume that you've already installed Blender 5.2 and Squishy Volumes 0.33. If you don't know how to do this, please check out the Getting Started guide. We start with a fresh Blender project and we select and delete the default cube. Then we find the Squishy Volumes UI, it's in the sidebar. We can start with the example setup, Boing Block. That is already quite close to the scene that we are going for. We can immediately see the result when we play the animation. Now you can see a lot of useful UI in the Squishy Volumes tab, but let's minimize everything except for the simulation panel. In the middle of the simulation panel, you can see the Record Input and Bake Simulation button. Click it now. By default, Squishy Volumes is using your CPU to simulate, but you can change that by switching to a GPU for the device. If you try rebaking now, it will be much faster. The current version of Squishy Volumes doesn't have adaptive timestep on the GPU yet. That means that we need to manually adapt the timestep sometimes. This is a min-maxing game. Set the timestep too high, for example 0.1, and the simulation fails. But set the timestep too low, for example 0.0001, then the simulation performance will suffer. For now, let's leave the timestep at 0.005. Let's add some additional input geometry. Go to the input panel, select the cube, and go into edit mode. Now just duplicate the mesh that we already have. Exit edit mode and rebake. Alright, if you look from the side, you will notice that one of the cubes is getting cut as it's falling down. Cutting is a super cool feature in Squishy Volumes, but we do not want it here. The cube is getting cut because the plane has open edges. Let's fix that. Select the plane and go into edit mode. Then just extrude the plane down. Exit edit mode and rebake. Now the cube is not getting cut anymore. Let's add some more input geometry. Lately I've been kind of obsessed with toruses. And whenever you feel like it, rebake. Let's add even more geometry. Oh, we need to adapt the timestep now. Let's decrease this by half. Okay, now it works again. Depending on how much input geometry you added, you might also run into a different problem, which is that Squishy Volumes exceeds the allowed disk space. To fix this, go to Overview and set the max disk space higher. We will discuss disk space in greater detail later in the video. Let's take care of the output visualization now. Close the sidebar and hide the overlay. Now select the output object and go to Modifiers. The default visualization is a geometry nodes modifier that offers us a few different visualizations. For example, we have points, what we see right now, and we have deformed cubes. I like this one a lot, but for this scene, let's go with reconstructed surface. Now if you take a closer look at our objects, you'll see that they are fused together. For example here, the two toruses are fused together. To fix this, we will split the input into several objects. But first, let's do some housekeeping. Add 2 new collections, one for input and one for output. Now move the input objects into the input collection and the output object into the output collection. Reveal the overlay and open the sidebar again. Select the input object and go into edit mode. Then go mesh, separate by loose parts. Alright, exit edit mode and verify that all the new objects are also inputs to the simulation. Now check also the output panel. Notice that the output is not immediately filled with all the new objects. Rebake the simulation and notice that most of our stuff is now invisible. Select the output collection and add all of the new output objects. We don't need the cube, as we have that already. And we can also skip loading most of the attributes. Deselect everything but sizes and transformation. Also deselect Add Default Visualization. We will reuse the visualization that we already have. Now make use of the collection to select all of the output objects. And control click the one that has the visualization already. Now press Ctrl L and copy modifiers. Now check out the output. With separate output objects, we get cleanly separated reconstructed meshes. Now there's just one little issue remaining with the output, and that is that the surface reconstruction will not respond to simulation resolution changes. Go to the input panel and have the grid node size. As you can see, only one of the output objects adapted to the new resolution. Select it and check out the modifier. The grid node size has a driver, but this is missing for the other output objects. To fix this, select all of the output objects and hit F3 and search for squishy volumes. There you find Add Drivers. Now all of the output objects have drivers. Let's also now rebake the simulation with this increased resolution. Okay, for this we need to decrease the time step some more. I'm trying half again. Yeah, that looks good. For the final simulation we can increase the resolution even more. But for now, let's do some shading. Hide the sidebar and the overlay again. Then split the view with the shader editor. Switch the left view to shaded preview. If you can't see the button, you have to scroll a bit. The default material on the reconstructed surface is a debug view of the initial position. We've disabled loading the initial positions for the other output objects, which is why only the initial one is showing it. Before we start shading the object, let's improve the environment. Switch from object to world. This is where you can change the background color. Add a sky texture. It says here some disk is not available. Change the renderer to cycles. We don't need a lot of samples for this scene, so let's decrease the number of max samples. This will improve the performance a lot. Also switch the device to GPU. One thing that I like to change in the sky texture is to increase the sun size to 10 degrees. This gives a bit softer shadows. Now let's shade the objects. Switch from world to object and select the squishy volumes material. Again, this is for displaying the initial position, but we won't be needing this. Let's add a constant color. Highly saturated, any color is good. crank up the transmission, and add some volume absorption. Make it the same color. Now I think this looks pretty good already, but it would be much more interesting if each of the objects had their own hue. Shift right click to bundle the noodles, then add a HSV node in between. Now we can modify the hue easily. You use a random value for each object. Let's join the split again. Yeah, this shading is really working for me. I'm already craving some gummy treats. Let's set up the camera. Reveal the overlay again. Find the camera. Then resize it. Then resize it again, but this time with respect to the cursor. Let's have a test render. Okay, without changing anything about how this looks, let's increase the resolution of the simulation again. With higher resolution in simulations, you need to be a bit careful with the disk space. Close the render and open the Squishy Volumes UI. Now have a look at the overview panel. Here in the overview, you can see how much space is currently occupied by the cache. And you can also set the max allowed disk space. You will get a simulation failure if this size is exceeded. Let's try this now. For the higher resolution, we'll need a lot of space. So let's set the max disk space to 100 gigabytes. It is also advisable to put the simulation cache on a separate disk from your operating system. The default cache location is in the temporary directory. That means that after reboot, everything will be deleted. This is usually what you want. Of course, this will not happen if you change the cache location to somewhere else, for example to another disk. There is currently no cache migration utility. However, you can manually move the cache and then reload the simulation from there. But with the GPU acceleration, this is usually not worth the hassle. And you can just rebake. Okay, so we actually need to reduce the timestep a little bit further even. Let's go to 0.0002. Now after about 20 minutes, the simulation is done, and we can render the animation. Because of the way the Squishy Volumes updates the data in Blender, the interface needs to be locked for rendering. And this is the result. As you can see, there are a few flickering artifacts that are very prominent on the cube. This doesn't always happen, and here's another variation of that scene. In any case, we can mitigate this flickering artifact a bit. Open a split again. This time go to geometry nodes. If you don't have it open already, select the Squishy Volumes particle group. Then locate the final menu switch and insert a smooth geometry node. Just give it a few iterations and a little bit higher weight. You can have a look at the difference by toggling this node. Now, let's enjoy the final animation. Leave a like, share, subscribe, join our Discord, and may your simulations always be stable and happy squishing.